This is a presentation for the Photon Cloud API plugin in the Unreal Marketplace. This is like a story of the development of the plugin. Um, what we are going to see in this tech talk, we're going to see what is the Photon engine, the plugin creation and evolution, the modules it has, how they work together. There is a real-time module, a chat, text chat, and a voice chat modules. Then we will see some examples, and then if you have questions and we have time, we will see. So what, where, and who? More info about this NG plugin. What is Photon Engine? Photon Engine is a multiplayer service with cross-platform support, and it is used currently by thousands of developers for different platforms. You can see there are different parts in the Photon Engine services. They have PAN or PUN. This is for Unity. Then you have a Bolt library and a Quantum library. But this is some, let's say, it has some time, so it's a little bit old. Now they have this approach, Fusion and Quantum. The plugin I did is not Fusion or Quantum, it's just real time, playing real time, or the pure Photon Cloud, the original. It is comparable to the plugin in Unity, or the same. It's the same platform. And then you have Photon Voice and Photon Chat. And there is also a plugin for video, or SDK for video, but we are not seeing this one here in this tech talk. Why you should be using Photon Cloud or Photon in general? So when you use Unreal Engine and you want to do a multiplayer game, you have to use the client server model. You have to host a server that is an Unreal instance of the server. That is usually is a dedicated server with no rendering on a Linux machine, probably. And that is based on the game acting as a server that hosts a session of a multiplayer game. So normally you use the online subsystem coming with Unreal Engine because it comes with all the replication and all the methods you will need. So you have in the number one, you have the server, and the number two are all the clients that connect with that server. So the approach using Photon Cloud is that you have a relay server, and this relay can be any kind of application. It could be an Unreal server or another application made in your desired language or platform. It could be Linux or Windows, but normally the Photon server is Windows, so yeah. So with this approach, you don't need an Unreal dedicated server. The server is in the cloud. So you have different clients that connect, and for example, the client number 3 can send a message that the client 1 is going to receive through the Photon relay, but it can also be sent to the client 2 if you want. And there is another option that is to send from client 3 to client 2, and there is no relay server in the middle, so you are sending a message directly. This configuration is a peer-to-peer configuration, so there is no need to host any server, but yeah, if you want, you could do the logic of the game in a real game and then use the master client, and this is a concept that we are going to see later. So where is Photon? Where are their servers? They have monthly active users of 400 million, and they are everywhere in the world. You see, they are in Europe, in Amsterdam, because they have very good nodes there. So they have this traffic of 4 petabytes per month for their games. So when you have to choose between cloud or server, why are you going to choose the cloud? Because you don't need to manage that server, and it auto scales for you. The server logic, although, is limited because you can control the server, and the logic is pure web hooks where you have to add your own logic in an external server, and that's more complicated. And yeah, you can use an Unreal server if you don't use your own Photon Cloud server. So that's the other option. Use your own Photon server where you have to host the server, but then you can choose the application you want to run in the server. There is an option to use plugins for the server, but that's only for the enterprise mode. For the cloud, you only pay for licenses depending on the users you have. For the server, you have to pay an additional license for the server or a different license. Yeah, it's a different one. Yeah. So you can see for multiplayer, you have the real time, that is the module that I have implemented in Unreal. And then we have voice and chat. Who is using this Photon Cloud? There are, as a case, there is a link here you can check later, but there is a lot of games, mostly indie games, but there are other companies, big companies using Photon Cloud. This is one of my clients, Turbo Rocket Games. They use my plugin, the first version I did long time ago, for another engine that is not Unreal, that is called Shiva, and it is also C++, but the code that the game engine uses inside the game is Lua. It's a script language for quickly prototype or doing gameplay really fast. So I did all the translation from the API to C++ and then to Lua, so they can use that in this game. And yeah, this guy is from Ukraine. He did a lot of games, mostly like this one. It's like a simulator with animals. So he has like this kind of model of game. He made one game, and then from that one, it kept growing until he has this very good game for. You see, they have a lot of items and customizations, and they have a lot of players. Yeah, so you can see all the games they have in Google Play and App Store. And this one, I think this one is one of the most played. You can see the numbers in the installs. They have 50 million installs. That translates to, I don't know, could be 10 or 20,000 users a month. But yeah, up to 50 million users per app per platform is a very good number. And that was the number of users using the first version of this plugin long time ago. So what was the creation, evolution, and purpose? How it was to create this one? So if you need to prototype quickly, it's better to have like Lua or blueprints. You can config and run pretty fast. You don't have to search for all the libraries you need. It's really easy to just download the plugin and do a game. So you can iterate on the gameplay features, play really fast. Like having an easy matchmaking process is really important when you are developing multiplayer games and you want to test different features you are developing. Another important feature is to have the same code for all the platforms, so you can cross-play with them. For example, with the console or different mobile platforms like Android or Apple. So there are basic concepts that are integrated inside Unreal that comes from Photon Cloud. The first thing is the regions. The regions are like the zones of the world where that you use to connect. There are different methods to select these zones. You can select it manually, or you can allow to ping test those regions, so you get the best ping. Then there are something like looks like an RPC, a remote procedure call, but it's like an event with a number and different arguments. And this is the base layer of communication, sort of. Then you have the player or room properties. These properties lives with the room while the room is running. So this is real time only. It's not persistent. Then you have the matchmaking for these rooms, and there is a lobby where you can see all the rooms of other games, so you can get properties that are shared from the game rooms to the lobby rooms, so you can see them, use them for the matchmaking, and then you can filter the traffic, for example, like a replication graph, but it's made by Photon. Um, so you can select different groups, and you can filter these groups like in a world or a cell grid. Each cell will be your group, so you only send information or receive information from your grid, um, from your cell grid, something like that. Yeah, so the first version of the plugin was in 2013, and it was C++ and Lua. Yeah. After that, 3 years later, I had to make the first version for Unreal Engine for Tring. This was a really hard challenge because there was nothing. There was a sample project, but um, Exit Games they only do C Sharp and Unity, or that is their main focus. They don't do a lot of C++ code, so they don't use pretty much Unreal. They use more Unity, and I had to do everything from their sample project. I made a lot of mistakes. So after I have a decent version of the plugin, I felt uh, with confidence to publish it in the marketplace. So the first version was for 4.22, even though the plugin was not really good, I think. So I had to improve it a lot. And this is something you learn when you have something in the marketplace, because people is going to be um, coming with their experiences with your plugin, and they are the users, the clients, sort of your plugin. So usually they are making games with your plugin, so all the things they bring are to improve it. So I did different versions, and after all these user comments, I have to change the architecture of the plugin, and I changed that from an actor approach to a subsystem approach, and that's what was a really good thing to do. There is someone that he came from Jaeger. There is a company that use Unreal for more than 20 years, and they have a lot of experience with the engine. And there was this guy, and he said that the plugin was not good, and he left a very bad review, and that was good for me because it was very constructive. Or I had to learn another way to do things. So I fix all the things in the plugin, and I add the voice module. So this year I published this latest voice module, and this module was 6 years in development from Photon. I did the first version of the voice module in 2017, but it was using the real-time connection, not the voice connection. those are different SDKs. We didn't have access to the voice SDK until this year, so I only had a few months to do that. But after some testing, looks like it works. Let's see how it's going. So how do we use this plugin? Because from the idea to the execution, there is a big way, a long way. So you have a Photon dashboard where you have all your application for all the SDKs or the modules. You have the application for the voice, the chat, and real time where you can configure that. So you have to set in the configuration those app IDs in the project preference of the plugins modules. That's it. You can just run directly the game, and this is something that is really hard to do if you grab the SDK, because you have to fix a lot of things in the code and do your own implementation in C++ if you don't have this plugin. So I think this is something that will help you to understand and do it faster. Basically, we need to connect and authenticate. Sort of, this is like doing a login. So you do the login and the authentication depending on your platform. Sometimes you use Steam, or you can use I don't know, the PS Station network. Then you have to join the lobby to see the rooms. There is the matchmaking after you see the rooms. When you join a room, there is a lot of events that is coming to all the players that are in that room. Then you have to communicate with the clients that lives in the room or that are playing the same game. So there are different ways to communicate, different paths. So basically, when we connect, we get the room list. This is not necessary, but you can just join a random room if you want. But in this case, what we are doing is to use an initial properties, so we can set these properties for the room when we create the room. If the room already exists, then we just join the room, but we can't set the properties. We receive the properties that are already there because the room is already created, so we receive the updated properties. In the case of the voice chat, it's pretty similar. You list the audio devices you have, and then you use one of those devices that is a microphone, probably. You can set the different parameters like the sampling rate or frame duration, the bit rate, the number of channels, the channel ID, and you create this voice pusher is going to use a capture from the microphone and in Unreal as a component, and then that component is going to send the information to the API. You can configure who is going to receive that, if you're going to use a direct connection, or this is more like a relay server. So the plugin modules that this is made of and how this works. We have the real time, that is the base layer for multiplayer games, the voice module that basically is the voice chat, the text chat, that is the chat module, and we have other modules in the project because we have different ways of doing things. So I provide some modules in the for games because people ask me all the time about how do you do this using Photon. How can I do Fall Guys or Among Us? I have to like doing some modules for them. So the first time you connect, the connection is made with TCP or UDP. The first connection is made to the name server. The same name server is going to direct you to the master server, that is the region you select. Finally, from that master server, you are going to the game server when you join a game, for example. The AUTH is optional, but if you want to use a provider, then this is the scheme. Normally, you see if the provider is configuring the dashboard for that platform. For example, for Steam in PC, you have to configure all the tokens and the authentication in the web page of Photon, and then you have to use the same configuration in the plugin. So using that, you do the login, and then the client is approve or reject. And this is in code, another example using PlayFab. So using the SDK from Microsoft, you can do a custom login and use this configuration in the Photon dashboard, makes you be able to connect with PlayFab. So for the real-time model, this is how we make the real-time part. So the Photon engine is based in an INET or binary protocol. This INET is very old, but the guys in Photon, they made their own version of this protocol. So the data is sent on a per message basis over the binary protocol. They have the documentation where they describe the messages sizes. And then we have different binary protocols that are organized in several layers. So the lowest level is UDP. Then you will see you have the UDP header, the init package header, the command header, and then you have the operation, the result or event, and then there is a command. So any UDP package contains this kind of header and at least one command. This command carries the message that is, for example, when you join a room, there is a message with an operation, a result of this operation. There is an operation header for the data you provide. On the client side, the operation parameters and their values are aggregated within a hash table. The hash tables are like the basic data structure that contains more data than one variable. So they can resemble by a byte key, and the operation requests are streamlined and use less byte than any regular hash table. The results and events are encoded as in the same way as operation and parameters. The result always contain an operation code, a return code, and debug string. So you can see when you have an error when you try to do some operation, you can see what is the error coming from the server. You can serialize your own types, and this is how I make all the types for the plugin. So for example, these init commands, you have the connect command, for example, that is sent by a client, and the server is going to verify. Normally, it works the same for when you send other types of commands. There are different sizes depending on the types. These are the sizes for C#, but it's very similar to C++. So I had to do a data conversion because Photon needs all the data you want to share to convert to their own types. So what I did was a JSON module, and with this, well, this is a class. With this class, you can convert any data from Unreal to JSON, and from JSON, I do the automatic conversion to the Photon types. And you can use dictionaries and hash tables, and there are tools to convert between them. You can have different levels like JSONs inside JSON, so that translates to dictionaries or hash tables inside another hash table or dictionaries. This is a basic example of how this is done. So you can create a JSON and from that node, you have a JSON field or a JSON class instance, and you can start to add data to that JSON. And like, for example, you can add an array, and then you can make a list of the people you want to receive, or you can select the default list of people, like for all the players that are not me. And that's the message will be shorter in size. And you can choose if you want that operation to be reliable or not. So normally there are player events like you just saw, and that's everything related to a player that is also known by its player number. So each time a player gets connected, it receives a player number. If you disconnect and reconnect, that depends on an option. If you leave an option as true, like you are going to come back after you disconnect, then when you come back, you have the same number, the same player number. So the first player number is going to be the master. So each player has properties. So only a local player can modify its player properties, but anyone else can read those player properties. This is for security. But the room properties are global, and in this global space, anyone can modify the room properties. So there are game room properties and there are lobby properties. So normally you have game room properties where you set everything you want for the game to be shared with other players. So even if players leave, you will have those properties until the room is destroyed. So you can select from those properties which ones do you want to have in the lobby as list, because not all the game room properties are listed in the lobby room properties. And the master player, you can use that to control the flow of the game, because the AUTH is not like in a dedicated server, and you have no Unreal dedicated server. Normally, you have a Photon server that has no Unreal instance. It's just a normal application. And in this case, if you want to control the flow of the game with the master can change. And there is an event for when the master change. You have to move the properties from the master to another player that will become the master. And that could be complicated things, but yeah. The actor events. This is a way you can use as fake RPC. I also add a replicator component, so you can attach a replicator to any actor and replicate properties and use that to send messages and other stuff. So you have the room properties. In the room properties, for example, you have the property R2D2, you have the max players, and if it is open or closed. The name is the name of the room, and the max players is something you have to set before you create a room for the first time, and you can create that room open or closed, and you can change this condition later after the room is created. You can open or close that. Then you have the cache for the events, because when you send a message, that message is only for the players that are there, but you can cache that message. So when a new player comes into the room, that event will trigger as well because it is in the cache. Then you can remove that from the cache when you think it's the time. And this is another example for a player's properties. You can have different names. The name is like you have the player name, and I also implemented the nickname. So you have the player name is common for the API, but I add the player color and the player nickname. So the chat module is how we do the text chat. Normally you set the app ID, the region, the connection mode in the config, and then just connect and out like in real time. But in this case, this is not like real time. You have to subscribe to a channel if you want to receive or send messages. Then you can send messages to other players that are in the chat room. And you can have friends, and those friends, you can subscribe to their status change so that you know when they connect. Normally you have, for example, two players, they subscribe to a channel, then they can send and receive messages from there. Optionally, they can send private messages with another optional option and an encryption option that you can enable. So if you add other player as your friend, you can have their states and see when they get connected. It's a very simple model. I think it's the easier of the three of them. But the voice model is more complicated. What is the flow? The flow of the voice model is that once you connect, the voice client will receive the raw voice data from the microphone, and you do that with Unreal with this voice model, and you create a voice capture, and from there you use a microphone input or an audio input device. This microphone data is split into different frames. That is these are arrays of unseen integers of 8 bits. So you send that, and this is the way I did the voice connection like 5 years ago, but it was so bad because I didn't use the encoding. So Photon add the encoding with Opus, and they do a really good job. Like we can use that for any platform. It's really fast. So the coded frames are sent with load balancing application. The load balancing application is something that will detect the best way to send a message, balance the lag depending on your connection. So the Photon servers will have their own version, of the voice application, but we can have a voice application server. Yeah, right now the only way is to use their voice server, but we can use the direct mode. That is a peer-to-peer connection. If you want a faster connection between clients that doesn't rely on the server. So when the data arrives from the other client to my local player or the other way around. If I'm sending the voice data to another player and that player receive the data, these frames, then they are decoded again with the same library. These decode frames are then passed to the audio component that every player has for each connection. And then the audio component is going to push that using the sound procedural, a sound wave procedural, and then you will hear the sound. So there are some differences between TCP and UDP in the voice module. Unreliable UDP usually preferable over TCP for voice chat or any other video or audio transmissions, even though I only implemented the audio part. The behavior in case of package loss is delays for TCP versus a lower video or audio quality for UDP. You can simulate the network loss if you see what happens when you choose TCP or UDP. You could be hearing voice, the voice is missing. When you use TCP, the audio can jitter. The audio jitter buffer size will be larger than with UDP to compensate for these delays. So TCP is useful for audio quality debugging when you want to make sure that there are no transport losses and the codec does not need to recover those data, so that only audio input and output processing may affect the quality. TCP makes sense as a fallback protocol in the case of clients behind our router firewall settings and not allowing UDP. But UDP gives the better user experience and should hence be the default choice in production environments. It's preferable to have a couple of frames lost over time than having the incoming signal stopped until the lost package arrives, or having a large buffer to be able to wait for repeats without pausing the audio output. So yeah, once you connect, there is only a way to change between UDP and TCP, that is to disconnect and reconnect. But UDP is usually better when you are in production, and TCP is better for debugging. So what I did for the samples, I did a lot of projects. I did a rolling Photon Cloud, that is the rolling template from Unreal. So I make a sample with that using the connection, the AUTH, the lobby, the matchmaking, the synchronization between the players, like in color, name, location, rotation, creation of other actors. Then I did a chat and a voice chat. But yeah, like I said, other people, they always ask for me for more complicated projects like Among Us. That is for me this project Among Clouds. We have found some demos for different platforms, so if you want to try. For example, in this video, this is one of the samples I create from the networking features template that Unreal did. So I did everything that Unreal did with replication, but using Photon Cloud and not an online subsystem, but Photon Cloud real time. And there is another example for the chat, but basically this is the thing you will see the first time you want to know about how to do things. For example, for their variable replication, there is an example with this semaphore. So you send the message, the actor receive, and depending if the master is the one sending the message or the client, then it happens one thing or another. There are different cases. For example, this is a simple interaction that is sent over the network. You can see that I'm triggering the button sometimes, and I'm receiving the message through the Photon Cloud. Um, and then there are things that are more complicated in this example, like this part that is the, oh, sorry, the zones or the grid. So right now we have three zones here. You are always in the zone 0, so you can have 1 and 2. So if this player is in the zone 1 and I do something in the zone 2, I won't receive the message for that interaction. But if I'm in the same zone, then I will receive the same action. Like I said, that's something similar to the replication graph. This example is for actors using the replicator component. So you have an actor, and when other actor picks this actor, then it will spawn an actor with a replicator component. And I can see that it is attached to this player now. So yeah, there are some issues right now with Unreal Marketplace pipeline because they don't want to update the their Xcode. Right now, I have some users that use Mac, um, but when I update the plugin, they have no access to the plugin in their Mac, so I had to pass them this command so they can build their own version until Epic upgrades their Xcode. So from this kind of problems, you always learn something. We saw, at least I see that when they send me the problems that some builds have, they send me the full log, and I can see in the logs that they use the EC2 instances from Amazon, and they can build a particular version of the Unreal Engine and use that for building a plugin for a particular platform. Normally they have only Windows and Mac, so they run Windows and Android, and then they run Mac and iOS. But they don't do. I don't think they run Switch, Xbox, or any console. Mm, Maybe they do a small check. Anyway, this is something that is interesting for us as a business because we can learn how they do things that we can replicate. There are other things to see, like the new Fusion and Quantum, because they are now able to support up to 300 players per match without having to create your own server. Like I mentioned before, if you want to have your own Photon version of the server, you can have that. If you need, for example, to make a game like WoW, that you need really large rooms with a lot of players with no limitations, and you have to do your own logic in the server. The plugin is in the marketplace. Thank you. If you have any question, just it's time.